Hi students, welcome to this video where we will be discussing the basics of interest. Alright, so we will be discussing simple interest and compound interest. Let's get started. So over here we have Mr. Hen and we have Mr. Panda. Alright, now let's say that Mr. Hen lent some amount of money to Mr. Panda. Now in this scenario we can call Mr. Hen the lender and Mr. Panda the borrower. Now another set of words that we could use is creditor and debtor. All right, so in this case Mr. Hen is the creditor because he is the one who is lending the money, and Mr. Panda is the debtor because he is the one who's borrowing the money. All right, now what do we call this amount which Mr. Hen lent to Mr. Panda? This is called the capital or the principal. All right, now among both of them there will be some agreement like, hey Panda, you'll have to repay me after 2 years or 3 years. All right, there will be an agreement. So after the agreed time period is over, Mr. Panda will have to repay the amount plus a certain interest to Mr. Hen. All right, so this is the basics of interest. All right, so over here you can see that after a period of time, Mr. Panda is not only returning the amount borrowed, but he's also returning an interest, right? He's also being charged an interest. Now, why is this so? It's because there is value to money, right? Mr. Hen could have used this money for something else also, right? So say he could have invested this money in a business. So in that case, he would have made more money, right? So that's why Mr. Panda is charged an interest, which he has to add to the principal when he repays the loan. All right. Now, a quick side note over here. Over here, we have the word creditor, right? And debtor. Now, similar words that you might have seen is with respect to transactions for your bank account, right? So if you have a bank account and if money comes into the account, it's called crediting, and if money goes out of your account, it's called debiting. All right, so that's just a quick side note because it's similar to the words that you see over here. All right, so quick revision. We have learned that the creditor is the lender, the debtor is the borrower, and the amount is called the principal or capital, which is the initial amount that's being lent. All right, and the final amount which has to be repaid is the initial amount plus the interest that's being charged. All right, let's now go ahead and understand what we mean with simple interest. All right, so let's look at the same scenario. We have Mr. Hen who lent some money to Mr. Panda. Let's say it's $100, and let's say that they have agreed for simple interest of 10% per annum. Now let's try to understand what will happen after year 1, year 2 and year 3. All right. Now after year 1, Mr. Hen is eligible for a certain amount of interest. How much would that be? That would be 10% of the principal, right? Because they have agreed for 10% simple interest. That's equal to 10% of 100, which is equal to $10. So the interest that Mr. Hen is eligible for after year 1 is $10. This means that if he were to get his money back after year 1, he could get back a total of 100 plus 10, which is $110. All right. Now, if he were to wait for the second year also to pass, right, he would be eligible for another 10% of 100. All right. So that's again another $10. So this makes a total of 100 plus 10 plus 10, right? So 100 over here, 10 over here, and 10 over here. That's a total of $120, which Hen could get back after year 2. Now, on the same logic, if he were to wait for year 3 also, again he would get another 10% of 100, which is another $10. All right. So this is again 130. The total amount that he would be getting would be 100 plus 10 plus 10 plus 10, which is $130. All right. Now over here, the interesting thing that we must note is that the principal or the amount on which the interest is calculated is not changing or it's not increasing, right? The principal for which 10% was applied for year 1 is 100, for year 2 also it's 100, and for year 3 it's also 100, right? And that's equal to the initial principal which was lent, right? So this is the important point to be kept in mind when it comes to simple interest. All right, now let's try to understand what is different when you apply compound interest, and that will help us to clearly understand the difference between simple interest and compound interest. So let's try to look at compound interest over here. Now let's take that the same amount was lent, and let's say they had agreed for 10% compound interest. So what would happen after year 1, year 2 and year 3. So let's try to observe that. After year 1, he would get an interest of 10% of 100, which is equal to $10. All right. So you can see that there is no difference when you compare simple interest and compound interest if just 1 year is involved. So the interest over here was $10, and we had seen that at this point he could have got back $110, right? We had seen over here that at this point he could have got back $120, and over here he could have got back $130. That is if the case is simple interest. Now let's try to understand what would happen in year 2 if the case is compound interest. Now in year 2, he could have got an additional amount of interest of 10% of 110. All right. So that's $11, right? So over here, what is happening is the principal amount, or the amount on which the interest is being calculated, is changed, or it has increased, right? So over here, we found 10% on 100, which was the initial amount. But over here, we found 10%, which is the agreed compound interest on 110. How did we get this 110? This 110 is this principal 100 plus the initial interest. That's 100 plus 10. So that's how we get to 110 over here. And the interest is applied on this 110. So that's the difference when you look at simple interest and compound interest. So over here, you can see that the total would be 100 plus 10 plus 11. That is $121, which he could get back over here. Right? Notice that in the case of simple interest, he would have just got back $120, but in the case of compound interest, he can get back $121. Now, what would happen in year 3? Again, the interest of 10% would be applied on this $121, not on this $100. All right. So that would be 10% of 121, which is equal to $12.1. All right. So the total amount that he could get back at the end of year 3 is 121 plus 12.1. How much is that? That's equal to 133.1. All right. Now let's quickly revise two things. First, what's the difference between simple interest and compound interest? And then let's also try to understand the logic behind compound interest. All right. So I'll try to explain this after we quickly revise the difference between these two, which we've just seen. In the case of simple interest, the interest is always calculated on the initial amount, which is 100. So for year 1, it's 10% of 100. For year 2, it's 10% of 100. And for year 3, it's 10% of 100. But in the case of compound interest, the interest increases, right? It's calculated on the basis of the principal. But over here, you can see that the principal increases. For year 1, it was 10% of 100. For year 2, it was 10% of 110. And for year 3, it's 10% of 121. So you can see that the principal is increasing. This is the primary difference between simple interest and compound interest. Now, what's the logic behind this, right? So why is the interest being calculated on 110 over here and not on $100? Let's try to think about that. Over here, if Hen were to get his money back at the end of year 1, he could have got $110, right? That's as per simple interest and compound interest. So we have seen that it does not change for 1 year. So he could have got back $110 at the end of year 1. All right. Now he's not taking his money back at the end of year 1, and let's say that he's taking his money back at the end of year 2. So when we apply the logic of compound interest, it's as if for this period of time, Hen lent $110 because that's the amount he could have got back at the end of year 1. So he's not taking that money back. So it's equivalent to lending $110 for this 1 year period. That's why the 10% over here is calculated on 110 rather than on 100, which was the case for simple interest. All right. So again, we have seen the difference between simple interest and compound interest, and we have seen the logic behind compound interest, right? The same thing applies over here. He could have got $121 back at the end of year 2. Let's say he's not taking it back at the end of year 2, and let's say he's taking it back at the end of year 3. So that's equivalent to lending $121 for this 1 year period. That's why over here, the interest of 10% is calculated on $121. All right, now let's proceed and look at some more examples of compound interest and simple interest. Hi students, in the previous video, we have discussed the basics of simple interest and compound interest. All right. Now, just by knowing the meaning or the definition of these two types of interest, let's try to work out a scenario. First, we start with simple interest. Let's say $500 were lent at 5% simple interest. Now, let's try to understand what will happen in 3 years. All right. So let's try to calculate this, and by doing this, we're trying to put into practice the knowledge that we just learned in the last video. So initially we have $500. Now after 1 year, it has to increase by 5%. And 5% of what? 5% of the principal. Remember, in the case of simple interest, the principal never changes. So 500 after 1 year will become 500 plus 5% of 500. Now 5% of 500 is 500 into 5 by 10, right? So this is 5% of 500. That's equal to 25, right? So this 0 and this 0 can get cancelled. So you have 5 into 5 remaining over here, which is 25, and 500 plus 25 is 525. So 500 will become $525 after 1 year. Now, again, let's say 1 more year passes. So what will happen? This 525 will become 525 plus 5 by 100 into 500. Over here again, notice the interest is charged on the initial principal, which is 500. So 525, which is what we had at the end of year 1, plus 5% of 500, which is again 25. That's the same thing that we calculated over here. So 525 plus 25 is equal to 550. Now, let's say 1 more year passes. So what will happen? 550 will be increased by again another 25, right? So 550 plus 5 by 100 into 500, which is again 25. So 550 plus 25 is equal to $575. So if $500 are lent at 5% simple interest at the end of 3 years, this $500 will become $575. All right. Now let's try to understand what would have happened if the $500 were lent at 5% compound interest. So let's try to understand that. Now initially we have $500. Now it'll increase by 5%. So 500 after 1 year will become 500 plus 5 by 100 into 500, which is 500 plus 25, right? So that's again 525, which is the same thing that we got in the case of simple interest after 1 year. So that's 525 over here. Now what will happen when 1 more year is passed? Remember, in the case of compound interest, it's equivalent to lending this $525 for 1 more year, right? So the interest is charged on 525, and 525 will become 525 plus 5 by 100 into 525. Over here, notice the principal on which the interest is charged is 525. In the case of simple interest, it was 500, which was the initial principal. All right. So 5 by 100 into 525 has to be added to 525, and that amounts to approximately $551.25. Now let's say 1 more year passes. What will happen? Again, 5% of 551.25 has to be added to 551.25. So we get 551.25 plus 5 by 100 into 551.25, which is approximately $578.8. All right. So remember, this over here is equivalent to lending $551.25 for 1 year at 5% interest. So that's why the interest is calculated on this amount. All right. So again, one more way in which you could look at this is this over here. This 525 is nothing but 1.05 into 500. How did I get that? Over here I have 500 plus 5 by 100 into 500, right? So let me make some space over here and let's explore how I got this over here. So I'm writing this expression over here. That's 500 plus 5 by 100 into 500. Now let me take 500 out, which is common, and over here I am left with 1, and over here I am left with 5 by 100. All right. Now 5 by 100 is 0.05. So 1 plus 0.05 is 1.05. So this thing in the bracket is 1.05 and you have 500 outside. That's how I get 1.05 into 500. All right. Now let's proceed. if you look at what we have over here, this could be written as 1.05 the whole square into 500. How did I get that? Let's try to understand that. Now another way of this writing this is 1.05 into 525. This logic is the same, right? So you have 525 over here and you have 525 over here. If I take 525 out, in the bracket I would have 1 plus 5 by 100, which is the same thing which I had over here, right? Instead of 500 I would have 525 outside. That's how I get 1.05 into 525. Alright, now we have already found that 525 is 1.05 into 500. So if I replace this 525 with 1.05 into 500, I would get 1.05 into 1.05 into 500, which is nothing but 1.05 the whole square into 500. Alright, so let me make some space over here and explain this again. We have seen how we got 1.05 into 525 based on what we had over here. Alright, so let me write that over here, 1.05 into 525. Alright, now we have seen over here that 525 is nothing but 1.05 into 500. So let's replace this 525 with 1.05 into 500. So this expression over here will become 1.05 into 1.05 into 500, right? So that's how I get 1.05 the whole square into 500. Alright, now similarly over here, what actually is happening is I can write this as 1.05 the whole cube into 500. Again, we'll see this when we discuss the formula of compound interest. Alright, so that's in a future video, but over here I'm just explaining the logic behind it. Alright, because that's very important to develop a solid understanding of these concepts. Alright, now again let me show you one more thing over here. We have seen that when $500 at 5% compound interest, when we did the calculation for 3 years, we have seen that what happened is we went from $500 to $578.8. Alright, so let's try to understand that over here once again. So 500, when it increased by 5%, it became 525. Now 525, when it was increased by 5%, it became 551.25, which is what we got over here. And when 551.25 increased by 5%, it became 578.8. So that's what we have seen over here. Hi students, in the previous videos, we have learned about simple interest and compound interest. Now we did not discuss any formulas. We just try to understand what we mean with simple interest and compound interest, and we have also seen it in action. Now in this video, let's try to get a little bit deeper and let's try to understand the formula to calculate simple interest. The formula to calculate simple interest is PTR by 100, where P is the principal, T is the time period, and R is the rate of interest. Alright, now let's try to understand this formula with an example over here, right? So that's the best way to try to learn this formula. So let's go ahead and solve this problem. Johnny lends $1,000 to Bob at 10% per annum for 3 years at simple interest. Alright, how much does Bob have to pay Johnny at the end of 3 years? So that's the question. Alright, now without the formula, we have seen in the previous video how we could go ahead and calculate this. Like we go ahead and try to find out what would be the scenario after 1 year, after 2 years, and after 3 years. Alright, now over here, let's try to use this formula over here and directly try to find the simple interest. Now simple interest is PTR by 100. In this case, the principal is $1,000, right? And the time period is 3 years and the rate of interest is 10% per annum. So let's plug in these values. We get simple interest is 1000 into 3 into 10 by 100. Alright, so these two zeros cancel out and that is equal to $300. Alright, so the simple interest at the end of 3 years will be $300, and the amount that Bob would have to repay or give back to Johnny would be the principal, which is 1000, plus the simple interest. Alright, so the amount that has to be repaid is equal to 1000 plus 300, which is equal to $1,300. So let's quickly revise what we learned over here. Simple interest is equal to PTR by 100. So you should know this formula. Alright, now again, you could easily understand why this is the case. Now let's quickly try to link it with what we learned before. So initially it's $1,000. After 1 year, what will happen? 10% of 1000 would be added to it, which is 100, right? So 1000 will become 1100 after 1 year. After 2 years, again 10% of 1000 would be added to this. That is 1100 will become 1100 plus 100, which is 1200. And again, after 3 years, again you have to add $100, which is 10% of 1000, and you get to 1300. So that's the 1300 we have over here. Now PTR by 100 gives us the sum of this 100, this 100, and this 100. So 100 plus 100 plus 100 is equal to the 300 that we got over here. All right, now there are some more intricacies or nuances which you should know about this formula. So let's try to modify this question slightly to go ahead and understand this. In this question which we just now solved, we had 10% per annum for 3 years. All right, now I want to demonstrate to you that the time period and the rate of interest are related. All right, so let's have a different question, a slightly modified question. Let's say the question said 10% simple interest for every 6 months, and let's say the question was asking what is the amount that Bob has to repay at the end of 3 years. All right, so again, what's the difference? Over here it's 10% per annum, but over here it's 10% every half year or every 6 months, and the time period is 3 years over here. All right, now over here we have the interest rate for every 6 months, and the time period is in terms of years. So what you should do is you should convert these two into the same time period. All right, so let's keep 10% for every 6 months. All right, now if you were to convert this into half years, not the 10%, the time period. All right, so this is 3 years. Again, remember what we're trying to do is we're trying to convert these two into the same time period. So over here it's every 6 months. So let's convert 3 years into X number of time periods, where each time period is 6 months in length. So 3 years is equal to 3 into 2, that is 6 time periods of length 6 months, right? So 3 time periods of 1 year is equal to 6 time periods of 6 months. All right, now in this case we have converted both into the same time period. Our interest rate is for 6 months, and our time periods, that is 6, is also in terms of 6-month durations. Now we can just apply PTR by 100. All right, so we get the simple interest is equal to 1000, which is the principal. All right, and the time period is 6, this 6 over here. All right, and the interest rate is 10. So we apply the formula 1000 into 6 into 10 by 100, and that's equal to $600, and that gives you the simple interest. All right, now you could also convert this into years, right? So let's try to do that also quickly. Let's make some space over here. Now over here what we did was we converted them, both of them, into half year time period, right? Now let's try to convert it into 1 year time period. What would happen? This 10%, if it is for 6 months, what would happen for 12 months, which is 1 year? That would be 20%, right? So if for 6 months is 10%, for 12 months or 1 year it would be 20%. Now you could keep 20%, and then you just need to keep it as years itself, and then take 3 years. Again, if you apply it, you would have 1000, which is the principal, into the time period, which is 3, which is what we have over here, into the interest, which is 20% by 100. Again, you will get the same value, which is $600. So remember, the point to be kept in mind is you need to have the time period and the rate of interest in the same time period. Hi students, in this video, let's put into practice, or let's apply what we've learned and solve a problem. So over here we have a question. Let's read it together. The interest obtained on a sum of $8,000 for 5 years at simple interest is $1,200. Find the rate of interest. All right, now pause the video and go ahead and solve it on your own, and then we'll solve it together. All right, we are back. I hope you've been able to solve this question. Let's do it together now. We know that the simple interest is equal to PTR by 100. Now in this case, it's given that the simple interest is $1,200. All right, and it's given that the principal is $8,000, and it is mentioned that the time period is 5 years. We have to find the rate of interest. So let's plug in these numbers. We have 1200 is equal to 8000 into 5 into R by 100. Now let's simplify. We can cut these two zeros. All right, now we have a 0 over here and over here, so let's simplify. Now again, let's take out the common factor of 4 on both sides. We get 30 over here, and we get 2 over here, and let's cancel 2 from both sides. We have 15. So 15 is equal to 5 into R. Therefore R is equal to 15 by 5, which is equal to 3%, and that is answer option B. Hi students, let's do this problem. Sarah borrowed $800 at the beginning of the year for 10% interest per year. She was planning to return it by the end of the year, but because of some good events in her life, she was able to repay the loan after 9 months. How much interest did she have to pay? Alright, so pause the video, go ahead and solve this on your own, and then let's solve it together. Alright, we are back. I hope you've been able to solve this. Now let's go ahead and solve it together. Now we have to find out how much interest she had to pay. Alright, now the principal that she borrowed is $800, right? The time period for which she had to borrow the money is just 9 months, right? And the rate of interest is 10% per year. Alright, so let's write this down. The principal is $800, the time period is 9 months, and the rate of interest is 10%. Now if she were to repay it after 1 year, she would have to pay 10% of 800, which is $80, right? Now she repaid it faster than that, right? She just took 9 months. So definitely the answer is not 80, it's not 90, and it's not 100, right? It has to be less than 10% of 800, which is 80, right? So if she had repaid it after 1 year, it would have been 80. She's doing it faster than 1 year. So logically she'll have to pay less interest, right? So the answer is one among A and B. All right, now let's proceed. Remember, it's based on the the concept that we have discussed. The rate of interest and the time period should be in the same unit, right? So over here you have 9 months, and this rate of interest 10% is for 1 year. So let's convert 9 months into years. All right, so we know 12 months is 1 year, right? So 1 month is 1 by 12 of a year, and therefore 9 months will be equal to 1 by 12 into 9 years. So 9 months is equal to 9 by 12 years. All right, so 9 by 12 can be simplified as 3 by 4. All right, now we know that simple interest is equal to PTR by 100. All right, let me make some space over here. We know simple interest is equal to PTR by 100. We have the principal as 800. The time period is 3 by 4 of a year, and the rate of interest is 10% per annum. Now let's plug in these values. This amounts to 800 into 3 by 4 into 10 by 100. All right, now let's go ahead and simplify. We have 2 zeros and 2 zeros over here, so those can cancel out, and then we have 8 and 4, so we cancel this 4 and we are left with 2 over here. So the answer is 2 into 3 into 10, which is equal to $60. All right, so that is answer option A. Remember, you could also convert the years over here into months, right? So just the only thing is that the rate of interest and the time period has to be in the same unit. All right, so over here, let's say you have 9 months as the time period. In that case, you will have to convert the rate of interest into months. All right, so it's 10% for 12 months. So for 1 year or for 1 month, it would be 10 by 12% per month. All right, so I'm just showing you the other way. If you were to convert both into months, then what is the simple interest? That would be 800 into the time period would be 9 months, and the rate of interest is 10 by 12% per month. That's 10 by 12, and percentage means per 100, right? So you have to have 100 in the denominator. All right, so over here, that's PTR by 100. Now when you simplify this, again you'll get the same value, right? These two cancel out. You can see it's the same thing. Over here you have 9 and 12. I can cancel that. I can take out 3. I'm left with 3 by 4. I take this 4 and I have 2 over here. Again, I get 2 into 3 into 10, which is 60. So it does not matter, right? The only thing that's important is the time period and the rate of interest should be in the same amount of time. All right, so over here we have converted both into years, or you could convert both into months. All right, so I hope you've been able to solve this question. See you in the next video. Hi students, let's do this problem. Andy borrowed $800 at the beginning of the year. After 3 months, he borrowed another $1,600 at double the initial rate of interest. At the end of the year, the sum of the interest on both the loans is $320. What is the rate of interest per annum at which he borrowed $800? All right, so pause the video and solve this question on your own. And after you're done solving it on your own, let's solve it together. So pause the video and go ahead and solve it now. All right, we are back. I hope you've been able to solve this question. Now let's discuss this together. Now what's the scenario over here? He borrowed $800 at the beginning of the year, and after 3 months he borrowed another $1,600, all right, at double the initial rate of interest. So if he borrowed the initial $800 at R percentage per annum, he borrowed $1,600 at 2R percentage per annum. All right. Now at the end, the total interest which he had to pay was $320. All right. And we have to find out R. So that's the question. Now over here we have 800 into R by 100, right? Because the time period is 1 into 1. If I take it as 1 year, so that would be the interest which he had to pay on the $800 at R percentage, right? Again, remember, simple interest is equal to PTR by 100. So the principal is 800 and the time period is 1 year, and you have R percentage per annum. So 800 into R into 1 by 100. So that's the interest on the $800. Now what would be the interest on the $1,600? So that's where the tricky part is. If you are able to put both the interest rate and the time period into the same units, then you will be able to solve this question. All right, so let's take the interest as 2R by 2R percentage. All right, because it's given that it's double the interest. All right, and it's after 3 months. So he paid the money, that's $320 at the end of the year. So what's the total number of months for which he borrowed $1,600? That's 12 minus 3, right? After 3 months, so January, February, March is over, right? So he just has to pay interest for the remaining 9 months. All right, so 9 months is what the time is, or the duration of time is for which he borrowed $1,600, and 9 months is nothing but 9 by 12 years. 9 by 12 years is nothing but 3 by 4 years. That's the same thing that we saw in the previous question. All right, so again, 9 months is the same as 9 by 12 years or 3 by 4 years. So let's again apply PTR by 100. That would be 1,600, which is the principal, and 2R is the rate of interest, and the time period is 3 by 4, and you have 100 over here. So this is the amount or the interest which he had to pay on $1,600. This is the interest which he had to pay on $800, and it is given that the total is equal to 320, and we just need to find out R. All right, so let's go ahead and simplify this. I have 2 zeros, I have 2 zeros, and I have 2 zeros over here and 2 zeros over here, so I cancel out these. All right, so what does this become? Let me make some space over here. All right, let me make some space. So this simplifies to 8R over here. I just have 8 and R plus 16 into 2R into 3 by 4. All right, so this 4, I have a 4 in the denominator, and 16 has a factor of 4, so I cut that. So I'm left with 4 into 2R into 3 over here. All right, so I have R over here and I have R over here. So let me take that R out. Now this becomes R into 8 plus 24, right? This is 8, which is the 8 over here, and 4 into 2 into 3, that's 24. That's the 24 over here. So R into 8 plus 24 is equal to 320. 8 plus 24 is equal to 32. So we get 32R is equal to 320, or R is equal to 10%. All right, so that is answer option C. Hi students, in this video, let's go deeper with respect to compound interest. Now remember, compound interest is nothing but successive percentage changes. All right, so even though we are going to learn the formula in this video, for any practical purpose in the exam, the best way to calculate the compound interest is by using the concept that compound interest is nothing but successive percentage change. Now let's take an example. Let's say you are giving somebody $100 at 10% per annum for 4 years at compound interest. So this is the scenario. Now at the end of 4 years, this will become 100 into 1.1 to the power 4, right? So this is what you would be getting back at the end of 4 years. Now why is that so? That's because after 1 year it will be 100 into 1.1, and after 2 years it will be into 1.1. After 3 years it will be into 1.1, and after 4 years it will be into 1.1, right? So we have already seen this. The interest is applied on the final amount, right? So what's actually happening? 100 will become 110 after 1 year, right? So this was increased by 10%. Now after 2 years, 110 will be increased by 10%. So you have to increase it by 10% by multiplying 110 into 1.1, right? So that's how you get 121. So this is 1.1 into 110, which is nothing but 1.1 into 1.1 into 100. That's how we have this expression over here. So after 3 years, it will be 1.1 into 1.1 into 1.1 into 100. And after 4 years, it will be 1.1 into 1.1 into 1.1 into 1.1 into 100. So that's what we have over here. All right. So you can see that it's very difficult to calculate 1.1 to the power 4, right? So the better way is to treat it as successive percentage change. So you find it like this. Instead of trying to find 1.1 to the power 4 and to multiply that value with 100, the better method for the exam is to find it in this manner. That is, you increase it successively. That is, you find 110 after 1 year, then you find 121 after 2 years. From there you go to 133, and from there you go to 146. Again, we'll see this in the following examples which we'll be solving together. But keep this in mind for practical purposes. Treat compound interest as successive percentage change. All right, now let's proceed and try to learn the formula for compound interest. The formula for compound interest is nothing but amount is equal to principal into 1 plus r by 100 to the power n. All right, so this is the formula for compound interest which you will find in any book. Now let's try to write what we mean with the various variables over here. A is the amount, P is the principal, R is the rate of interest, and N is the number of time periods. Remember, A is the final amount that you will get back at the end of N time periods. All right, P is the initial principal that you are lending. All right, and R is the rate of interest, and N is the number of time periods. All right, now as any formula, the best way to learn it is by applying it in a problem. So over here I have a problem. Johnny lends $1,000 to Bob at 10% per annum for 3 years at compound interest. All right, how much does Bob have to pay Johnny at the end of 3 years? So this is what we are trying to learn over here. And remember, before we go ahead and apply the formula, we have already seen how you can do this by using the successive percentage change, right? We have seen that. Let's quickly see that over here. Initially it's 1000, right? So you have to increase it by 10% for 3 years. So after 1 year, 1000 has to be increased by 10% and it will become 1100, right? Because 10% of 1000 is equal to 100. So you are increasing 1000 by 100 to get to 1100. Now this 1100 has to be increased by 10% for the second year, right? So 10% of 1100 is 110. You just need to put a decimal point over here, right? So you have to add it by 110. So that amounts to 1210. And again, you have to increase this by 10% for the third year. Again, 10% of 1210 is 121. You just need to put a decimal point over here. So you have to add 121 over here. And this amounts to 1331, right? So you can see that from 1000, we went to 1331. Right? So this is much better than calculating it as 1000 into 1.1 to the power 3, right? So that's what you're doing over here, right? You're multiplying with 1.1 3 times, right? But instead of calculating 1.1 to the power 3, treat it as successive percentage increase. All right, so we have already discussed this. Now let's proceed and try to learn the formula. It's good to know the formula. That's why we're discussing it. All right, now let's go ahead. We have the formula over here. A is equal to P into 1 plus R by 100 to the power N. All right, so again, that the formula is based on multiplying it with 1.1 only. So let's apply it. A is equal to 1000, which is the principal, into 1 plus 10 by 100. 10 is the rate of interest to the power 3 because we have 3 years over here. All right, so 1 plus 10 by 100 is equal to 1.1. So this amount is equal to 1.1. So this expression over here becomes 1000 into 1.1 to the power 3. All right, now if you can calculate 1.1 to the power 3, that's equal to 1.331. So 1000 into 1.331 is equal to $1331. Again, for calculation purpose, I would always advise that you treat it as successive percentage change. All right, so the amount after 3 years is $1331. So if you want to find the compound interest, you have to find the difference between the amount and the principal, which is 1331 minus 1000, which is equal to $331. So that's the compound interest. All right, so let's now go ahead and see a few different types of questions which you could encounter. All right, now this is the basic problem, right? We had 10 percentage at compounded annually and for 3 years. So that was the basic problem. Let's make some space over here. Now let's say if the question was 10 percentage per annum for 3 years, and if it mentioned that interest was compounded half yearly. All right. So if this is mentioned, then you have to convert both the interest rate and the time period into this time period mentioned over here. All right. So you have 10 percentage per annum over here. All right. So this has to be changed into half years. All right. So if the interest is 10 percentage per annum for half year, it would be 10 by 2, which is equal to 5 percentage. So you have 5 percentage per half year. All right. So, and again, you have over here 3 years. This 3 years also has to be changed into half years. So 3 years is equal to 3 into 2, which is equal to 6. So 3 years is 6 periods of half years. All right. So you have found the equivalent rate of interest and the equivalent number of time periods. Now you can just apply this formula over here. That is, you get 1000 into 1 plus 5 by 100 to the power 6. A is the principal is 1000, which is P. All right. And then the rate of interest is 5% and the time period is 6, which we have calculated over here. All right. So why is this actually? What's the logic behind this? Now let's try to understand that. So what is actually happening over here is I have 1000 initially. All right. Now the interest rate is compounded half yearly. So after 6 months, I have to apply an increase of 5%. All right. So I have to do this 6 times because I have 6 half year time periods. All right. So that's what we are doing it. That's what we are doing over here. We have changed 10 to 5 because it was compounded half yearly, and we have changed 3 years to 6 time periods because 3 years is equal to 6 half years. All right. So again, based on treating it as successive percentage increases, you would have to do 5 percentage increases 6 times. All right. And again, this is calculated as 1000 into 1.05 to the power 6. So that's what we have over here. Now again, if you want to calculate this, just treat it as successive increases of 5% and do it 6 times. So that's the best way to actually find the answer in a question. All right. So we have seen the case where in the question it's mentioned compounded half yearly. Now let's see one more case. Let's keep this aside. Now let's say we have 10% per annum for 3 years. And if it's mentioned that the interest is compounded quarterly. All right. So 1 quarter is equal to 3 months. All right. So 1 year is equal to 4 quarters. So Jan, Feb, March is 1 quarter, and that's how the next 3 months is quarter 2, the next 3 months is quarter 3, and the next 3 months is quarter 4. All right. So if it's mentioned that the interest is compounded quarterly, you have to change the interest and the number of years into number of quarters. All right. So we have 10% per annum. So that would be 10 by 4, which is 2.5% interest per quarter. And then you have 3 years. So 3 years is equal to 3 into 4. That's 12 quarters. Now you can just apply the formula over here. That is, amount is equal to 1000 into 1 plus 2.5 by 100 to the power 12. All right. So that's nothing but 1000 into 1.025, right? 1.025 to the power 12. Again, for practical purposes, you have to just increase 2.5% 12 times. Now, typically you won't have this type of a question where you have to actually calculate it. But again, if you have to do it, it's better than finding 1.025 to the power 12. All right. Now let's summarize what we have learned about compound interest. You can say that the formula for compound interest is A is equal to P into 1 plus R by N by 100 to the power T by N. All right. So we have seen earlier the formula as A is equal to P into 1 plus R by 100 to the power N, right? So I'm writing the formula in a little bit different manner over here. This is to take into consideration scenarios where it may be mentioned that the interest is compounded half yearly or compounded quarterly, etc. All right. So let's see what it means. A is again the amount and P is the principal. So no difference with respect to this formula over here. The difference is that you have R by N over here and you have T into N over here. All right. So what is that? Let's try to understand that. N is the number of times interest is compounded per year. All right. So if interest is compounded half yearly, then N would be equal to 2, right? If R is say 10% per annum, and if interest is compounded for every 6 months, that means it's compounded 2 times in 1 year, right? Because 6 months occurs 2 times in 1 year. In that case, you have to do 10 by 2. That's what we have seen, right? Now, if interest is compounded quarterly, that means it's compounded every 3 months, right? Or in 1 year, it's compounded 4 times, because this is 1 year. If you were to divide it into quarters, you will have 4 parts. So 1, 2, 3, 4. Interest would be calculated 4 times. So that's why you have to do 10 by 4. All right. So n is the number of times interest is compounded per year, and that's why you have r by n over here. All right. And if it is for t years, say it's 3 years. Now let's say that it's compounded half yearly. So you have to do 3 into 2, right? N would be 2 if the interest is compounded every 6 months, because 6 months occurs 2 times in 1 year. So over here you have n into 3 into 2. All right. So let's quickly summarize this formula. Actually, you don't need to memorize this formula. We have already discussed this in a logical manner. So I'm expecting that you already know this. You already know how to apply this. Now, again, quickly, let me write over here a few scenarios. Let's say R is equal to, let's say 20% per year per annum. And let's say the time period is 4 years. All right. Now, let's take 2 cases. Let's say it's compounded every 6 months. So I have compounded every 6 months. And over here, the second case is compounded every quarter, which is every 3 months. All right. So 1 quarter is 3 months. All right. So let's see what will happen to the rate of interest and to the time period. In the first case, where it's compounded every 6 months, this is 20% per annum. So for 6 months, it will become R by N, which is R by 2, right? So that's 10% every 6 months. All right. Now, if it's every 3 months, that's 20 by 4, which is equal to 5%. It's not 20 by 3, it's 20 by 4. Why? Because 3 months occurs 4 times in 1 year, right? So this is 1 year. This is 3 months, this is 3 months, this is 3 months, and this is 3 months. So you can see 3 months occurs 4 times in 1 year, right? So that's why 20 by 4 or 5%. Now, what would happen to the time period? If you're taking 6 month time intervals, then 4 years will become 4 into 2. That is 8 time periods, right? So over here you would have 8. T into N would be 8. And in this case, what would be the time period? You have 4 years and 1 year is 4 quarters. So you have to take 4 into 4, right? So you have 16 time periods in this case, because the interest is compounded every 3 months, and 3 months occurs 4 times in 1 year. So in 4 years, you would have 4 into 4, that is 16 time periods. Let's go ahead now and do some more problems. Hi students, let's do this question. Johnny lends $1,800 to Bob at 5% compound interest per annum for 2 years. Find the amount that Bob has to pay as interest. All right. So pause the video and go ahead and do this on your own, and then we'll solve it together. All right, we're back. I hope you've been able to find the answer to this question. Now let's solve it together. Now over here, it's compound interest. The initial principal is $1,800. The interest rate is 5% per annum, and the time period is 2 years. All right. Now we could do it as amount is equal to 1,800 into 1.05 to the power 2, right? Again, remember, for practical purposes, treat this as successive percentage change. So initially 1,800 has to be increased by 5%. Now, how much do you get? If you do that, you will get 1,890. All right. So how do you do this? The easy way to do this is first find 10%, because this is 5%, right? So first find 10%. To find 10%, you just need to put the decimal point one place from the right? So 10% of 1,800 is 180. Now to find 5%, just find half of it, which is equal to 90. So you just have to add 90 to 1,800 and you get 1,890. Now again, you have to increase this by 5% because it's for 2 years, right? So again, 10% of 1,890 is equal to 189, right? So 10% is 189, and to find 5%, you just need to do 189 divided by 2, which is equal to 94.5. So you need to add 94.5 to 1890, and that amounts to $1984.5. All right. Over here we are getting the amount. All right. Now over here we have to find the interest that Bob has to pay, right? So that would be the difference, because this is the amount. So to find the interest, we have to find the difference between 1984.5 and 1800, and that's equal to 184.5. And therefore the correct answer to this question is option A, that is $184.5. Hi students, let's do this question. Manu lends $1,000 to Andy at 10% compound interest per annum for 18 months, compounded half yearly. Find the approximate amount that Andy has to pay back. Alright, so pause the video and go ahead and solve this question on your own, and then we'll solve it together. Alright, we're back. I hope you've been able to solve this question. Now let's go ahead and solve this together. Now over here, notice that it is mentioned that the interest is compounded half yearly. Alright, so you have to convert the time period over here, that's 18 months, and the interest rate, that's 10%. You have to convert it into half years. Alright, so 10% per annum, that would be 10 by 2, that is 5% per half year. Alright, and then you have 18 months. Alright, so 18 months is equal to 3 periods of 6 months, right? So again, how do you do this? How do you find this 3? We have 18 over here. We want to know how many periods of 6 months, because half year is nothing but 6 months, right? So 18 by 6 will give you 3. So 18 months is equal to 3 periods of 6 months. So what does this mean? If you have 18 months over here, you can cut it into 3 parts, where each part is 6 months long. Alright, so we have done that. Now we have found that we have 3 periods of 6 months in this case. Now we can go ahead and find how much money he will have to pay back. Now remember, compound interest is nothing but successive percentage increase, right? So let's do that. We have to increase 1000 by 5% 3 times. So that's what we have to do basically. So let's go ahead and do that. When you increase 1000 by 5%, this will become 1050, right? How do you do this? When you increase it by 10%, that's 100. 10% of 1000 is 100. So 5% is 100 by 2, which is equal to 50. So that's how you get 1050 over here. Now you have to increase this again by 5%, right? So again, 10% of 1050 is 105, and you have to just divide this by 2. All right. Now over here, when you divide this by 2, you will get 52.5, right? So 52.5 has to be added to 1050, and that will give you $1,102.5. Now you have to again increase this by 5%. Remember, you have to do this 3 times, because it's 3 periods that we have got over here. Now when you increase it by 5%, how do you do this? Again, 10% of 1102.5 will be 110.25. Now you have to divide that by 2 to find 5% of that, which is 55.125. So you have to add 55.125 to 1102.5, and that will be equal to 1157.625. all right. So again, what we have done over here is nothing but doing 1000 into 1.05 to the power 3. That's the same thing. All right. So over here, what's the correct answer? The correct answer is 1158, which is 1157.6. Approximately that's equal to 1158, which is option D. So the correct answer to this question is option D. Hi students, let's solve this question. At what percentage per annum will 2000 amount to 5488 in 3 years if compound interest is applied? All right, so pause the video and go ahead and do this on your own, and then let's do it together. All right, we're back. I hope you've been able to find the answer. Now the best way to solve this type of questions is by using the options, right? So the percentage is given over here. So let's try the middle value. Over here we have 50%. Now we can either find whether this is correct, or if this is wrong, we can also find whether the answer is less than 50 or more than 50. All right, so that's why we start with the middle value. All right, so let's go ahead and try option C. And one more reason is it's easy also, right? It's 50%. Now if you increase 2000 by 50% for 3 times, what amount would you get? Let's try it. So when you increase 2000 by 50%, you'll get 3000, because 50% of 2000 is 1000. Now let's again do that. So 50% of 3000 is 1500. So when you increase 3000 by 50%, you get 4500. and when you again increase it by 50%, you will get 6,750. All right. Now you can see that this is what? This is more or less. You can see this is more than 5488, right? So this answer option is wrong. So that's one thing, and it has to be lesser than 50%, right? So we have also eliminated these two answer options. So the correct answer has to be one among A and B. All right. Now let's again try one more option. Let's try 40%. If you increase 2000 by 40%, you will get to 2800. How do you do that? 10% would be 200. So 40% will be 200 into 4, which is 800. So 2000 plus 800 will give you 2800 over here. All right. So let me write that over here. 10% of 2000 is 200. So 40% of 200 will be, of 2000 will be 200 into 4, which is 800. That's how you get 2800 over here. Now when you increase this again by 40%, you will get 3920. Again, how do you do that? 10% is 280. And to get 40%, you have to multiply 280 with 4. All right. And that amount has to be added to 2800, and you will get 3920. Now again, if you increase this by 40%, you will get 5488, which is what you have over here. Therefore, yes, 40% is the correct answer. That is answer option B. All right. So again, how do you do 40% increase over here? 10% increase is 392. All right. So 40% would increase would be 392 into 4. So how much is 392 into 4? That would be 1568. All right. So when you add 1568 and 3920, you will get how much? You will get 5488. All right. So that's the correct answer. Therefore, the correct answer to this question is option B. Hi students. In some questions, you may be asked to find the difference between the compound interest and simple interest. So let's look at these type of questions in this video. All right. So over here, I have a sample question. If the difference between the compound interest and simple interest on a sum of money is $75 at 15% per annum for 2 years, then find the amount. All right. So that's the question. Now let's say that the initial amount was P, which is the principal. All right. Now we will solve this same question in 3 different ways. All right. So we'll do that first just using logic. Then we will try to do a detailed solution. And thirdly, we'll try to solve the same question using options. All right. So this will be 3 videos. In the first video, which is this video, we'll try to solve this logically. Now let's proceed. Now over here, you can see that it's for 2 years. All right. So it's mentioned it's for 2 years. Now, if you apply simple interest for 2 years and if you apply compound interest for 2 years, what would be the difference between the two scenarios? Let's quickly note it over here. In the case of simple interest, what will happen? You'll have the principal. To the principal, some interest would be added, and in the second year, again the same interest would be added again, right? We have seen that many times. In the case of simple interest, the interest is always applied on the initial principal. Now, in the case of compound interest, what would happen? In the first year, it would be the same, right? We have seen that the simple interest and compound interest is the same if it's just for 1 year. All right. Now, in the second year, what is the difference? Again, over here, we are trying to solve this logically. All right. We already know what the meaning of compound interest and simple interest is. So just let's try to solve this logically. In the next video, we'll try to have a detailed solution. So what's happening in the case of compound interest is that interest is applied on this amount, right? It's not on the principal, it's on this amount. All right. So that means the difference between the simple interest and compound interest, which is $75, is actually interest on this interest, right? You can see that in the case of simple interest, this interest is on the principal, but the interest that we will have over here will be on this amount, right? So interest on the interest is not applied in the case of simple interest, but in the case of compound interest, we have interest on the interest as well. So this 75 is actually the interest which is applied on the simple interest for year 1, which is this I over here. All right. So let me again repeat the logic over here. Remember, we are just trying to solve this logically in this video. We will have a detailed solution of this in the next video. So the difference between the simple interest and the compound interest in the case of 2 years is actually the interest applied on the simple interest for the first year. All right. So that means this 75 is actually 15% of 15% of P. 15% of P is the interest for the first year, and we are applying 15% on this interest. That's the difference between compound interest and simple interest when you're just having 2 years. All right. So now that we have established this logically, let's try to calculate the amount. So 75 is equal to 15% of 15% of P. That's 15 by 100 into 15 by 100 into P. All right. So this is equal to 75. Now we can simplify this and find P. So over here, this becomes 5 over here. All right. So again, I cancel 5 from both sides and I get P is equal to 100 into 100 by 3. All right. So that means that's answer option C. Now in the next video, let's go ahead and look at a detailed solution for the same question. Hi students, in the previous video, we have solved this same question just by using the logical approach, by using the meaning of compound interest and simple interest. All right. Now over here, let's try to have a detailed solution. Now let P be the initial amount. All right. Now what will happen to P in the case of simple interest or compound interest? In 1 year, P will change to P plus 15 by 100 into P. Right. Now in the case of compound interest, for the second year, we will be applying 15% interest on this amount, right? We have seen that many times, right? So that will become 1.15 into P plus 15 by 100 into P, right? So let's simplify this. This is 1.15 P plus 1.15 into 15 by 100 into P by opening the bracket. All right. Remember, 1.15 P is nothing but P plus 15 by 100 into P, which is what we have over here. All right. So this is what happens when you apply compound interest. Now let's see what happens in the case of simple interest. In the case of simple interest, P will change to P plus 15 by 100 into P after 1 year, and after 2 years it will become P plus 15 by 100 into P plus 15 by 100 into P, right? We have seen that in the case of simple interest, interest is always applied on the principal. Now let's try to understand the difference between what we have over here and what we have over here. So this is the case of compound interest and this is the case of simple interest. We need to find the difference of these two because that's what is given over here. All right. So you can see that this part over here is the same as what we have over here. All right. So we just need to find the difference between this and this. All right. So let's keep this aside. So we are trying to find the difference between these two. Now this part over here can be expanded as 1 plus 15 by 100 into 15 by 100 into P, right? Because 1.15 is nothing but 1 plus 15 by 100. Now let's expand this by opening the bracket. This becomes 15 by 100 P plus 15 by 100 into 15 by 100 P by just opening the bracket. All right. Now let's look at the difference between this and this, right? That's what we have been trying to do. So you have 15 by 100 into P over here and you have 15 by 100 into P over here, right? So when you find the difference, it's just this term that remains, right? So the difference is equal to 15 by 100 into 15 by 100 into P, and that is given as 75. Remember, by using the logical approach, we had arrived at the same equation over here. This is nothing but 15% on the interest for the first year, right? Which is 15 by 100 into P. So this is 15% on the interest for the first year, and that is equal to 75. Now we can just go ahead and simplify this, right? So we get that P is equal to 100 into 100 by 3, which is equal to 10,000 by 3, which is answer option C. Now in the next video, let's go ahead and see how we can solve the same question by using the options. Hi students, in the previous 2 videos, we have solved the same question. In the first video, we solved this question logically. In the second video, we had a detailed solution. Now in this video, let's try to solve this question by just using the options. All right, so let's go ahead and do that now. Let's start with option A. Now you could start in any order. All right, so option A says that it's 20,000 by 3. All right, so let's try whether that's true or not. Now if option A is true, then first year's simple interest or compound interest would be 15% of the amount, right? Because we know that the interest for the first year is 15 by 100 into P, where P is the principal, right? So we are assuming that option A is correct. So that means P is equal to 20,000 by 3. So 15% of the principal would be 20,000 by 3 into 15 by 100. All right. So let's simplify this. So this amounts to 200 into 5, right? So that's equal to 1000. All right. Now, what would be the interest on this 1000, which is the first year's interest? So the interest on 1000 would be 15% of 1000, right? Now, 15% of 1000 has to be equal to 75 if this answer is correct, right? But you can see that 15% of 1000 is not equal to 75. 15% of 1000 in fact is equal to 1000 into 15 by 100, which is 150. You can see that 150 is double of 75. All right. So we can conclude that option A is wrong. Not only that, but we can see that we need half of 20,000 by 3, right? Because we got double over here. So to make this half, we have to change the principal and make it to half. So half of 20,000 by 3 is equal to 10,000 by 3, which is answer option C. So we have solved the same question by just using the options. You can go ahead and try 10,000 by 3 also, right? If we try 10,000 by 3, what would be the first year's interest? That would be 10,000 by 3 into 15 by 100. How much is this? So that's equal to 500, right? So you get 500. Now 500, if you take 15% of 500, if you get the answer as 75, then the principal is 10,000 by 3, or the assumption that we did initially is correct. So how much is 15% of 500? That's 15 by 100 into 500, which is equal to 15 into 5, which is equal to 75. And that is correct. That's the difference given over here. That's why the correct answer option is option C. Let's do this question. If the simple interest is 20% annual and the compound interest is 15% annual, find the difference between the interests after 3 years on a sum of $1,000. Now pause the video and go ahead and do this question on your own, and after that we'll solve it together. All right, we're back. I hope you've solved this question and you've been able to find the answer. Now let's go ahead and solve this together. Now over here, it's for 3 years, right? It's mentioned that this is happening for 3 years. So if P is the initial amount, after 1 year, it will become P1. After the second year, it will become P2. And after the third year, it will become P3. Now we have to find two cases over here, right? In one case, it's simple interest 20%. And the second case is compound interest 15%. Now we have to find the difference between the interests, between the simple interest and the compound interest. All right. Now we know how to find the simple interest. That's PTR by 100. So the principal is $1,000. The rate of interest is 20% and the time period is 3 years. So the simple interest is 1000 into 3 into 20 by 100. All right. So these two zeros cancel out and that leaves us with 10 into 3 into 20, which is equal to 600. So the simple interest is directly found, which is $600. Now let's go ahead and look at the compound interest. Now we have to look at it as successive percentage increase. So 1000 after 1 year, it will become how much? Let's try to find that. For that, we have to increase it by 15%, right? Because it's mentioned compound interest of 15%. Now 10% of 1000 is equal to 100, right? We have to just put the decimal point over here, one place from the right to find 10%. Now 15% is 10% plus 5%. All right. So we have found that 10% is 100. Now 5% is just half of 100, right? So that's equal to 50. Now 100 plus 50 is equal to 150. So 1000 will be increased by 150 and it will become 1150. So that is after 1 year. Now after one more year, again we have to find 10% and 5% of 1150. 10% of 1150 is 115 and 5% of 1150 is half of 115, which is 57.5. Now 15% is the sum of these two. Based on the same logic, 15% is 10% plus 5%. So this is just a quick way of calculation. So 15% of 1150 is 172.5. So you have to add this to 1150 and the amount becomes 1322.5. That's at the end of 2 years. Now again, there's one more year. So you have to again increase this by 15%. So 10% is 132.25 and 5% is 66.125. Now when you add this, you get 198.375. All right. So you have to add this to 1322.5 and you get 1520.875. So this is the amount at the end of 3 years. Now to find the compound interest, you have to find the difference between these two. All right. So the difference is equal to 1520.875 minus 1000. All right. So let me make some space over here. So that's equal to 520.875. So that's the compound interest. Now we have to find the difference between the simple interest, which is 600, and the compound interest, which is 520. All right. So that's approximately $80 or $79.125. Now this is closest to option number C over here, right? Which is $79. So therefore the correct answer to this question is option C. Hi students. So far we have learned about compound interest and simple interest. Now in this video, let's learn about depreciation. All right. So what is depreciation? Let's say you've bought a TV. All right. So this is your TV. Now let's say you bought it at say $1,000. Now after 1 year, this TV will no longer be worth $1,000, right? Because there's wear and tear. It has become old, etc. Right? So let's say it has become it's now worth $800, right? So you can see that it has reduced by 20%, right? So again, earlier in the case of compound interest, we saw an increase, right? So every year, say it was increasing by 15% or 20%. Now in this case, there's a decrease. You can see that there is a decrease of 20%. Now let's say every year the value of the TV is reducing by 20%. So this is the case of depreciation, right? You can see that it's very similar to the case of compound interest. The only difference is that over here we have a decrease. In the case of compound interest, we had an increase. So the formula for depreciation can be written as the final value is equal to the initial value into 1 minus r by 100 to the power n. Vf is the final value, Vi is the initial value, and then you have a rate of interest, and then again you have a time period, which is very much similar to what we had in the case of compound interest. All right. Now notice in the case of compound interest over here we had a plus, but in the case of depreciation we have a minus over here. Now let's go ahead and do a question where we apply depreciation. Let's do this question. 2 years have passed since you bought a refrigerator at $1,000. You want to sell it now. At what price can you expect to sell it if it is known that the standard depreciation of a refrigerator in the market is 5% per annum? Pause the video and try to do this question on your own. Remember, it's just like compound interest. The only difference is that you have to put a minus instead of a plus. So pause the video and go ahead and try to solve this question on your own, and then we'll solve it together. All right, I hope you've been able to solve this question on your own. Now let's go ahead and solve this together. Now initially the value of the refrigerator was $1,000. Now you have to reduce it by 5% because that's the depreciation, right? Now 10% of 1,000, that's equal to 100, right? How do we do that? We have 1,000 over here, and you just need to put the decimal point one place from the right. So that's 10% of 1,000, which is 100. All right. So we need 5%. So you have to just find half of 10%. That would be 5%, right? So that's 100 by 2, which is equal to 50. So you have to reduce the value of the refrigerator by $50. So that's 1,000 minus 50, which is equal to 950. So that's after 1 year. Now over here, it's mentioned that you are trying to sell it after 2 years. So you have to again reduce it by 5%. So 10% of 950 is 95. So 5% of 950 would be 95 divided by 2, which is equal to 47.5. So you have to reduce 950 by 47.5, which will give you 902.5. All right. So this is the value at which you can expect to sell the refrigerator. And you can see that that is answer option B. Hi students. We have discussed compound interest and we have also discussed the case of depreciation. Now, the case of population change is also very similar to compound interest. All right. So do keep that in mind. And over here we have a question. The population of city ABC increased by 20% for 3 years in a row. Today its population is 124416. What was its population 3 years ago? All right. So pause the video and try to do it on your own. I know we have not done any such question over here in this section, but let me just tell you that this is very similar to compound interest. So try to do this on your own, and after that we'll do it together. All right, we're back. I hope you've been able to solve this question on your own. Now let's try to solve this together. Over here, the best way to solve this is by using the options. All right, so over here, let's first try option C because it's 80,000. All right, so we can easily identify whether the answer is 80,000 or whether it has to be less than 80,000 or more than 80,000. And again, 80,000 is easy to check, right? It's a number with a lot of zeros. All right, so if the initial population was 80,000, if you increase it 3 times by 20%, if the answer is correct, you should be able to reach 124416. So that's how we try to check using the options. So let's go ahead and do that. So we have 80,000. Let's increase it by 20%. So 10% of 80,000 is 8,000. So 20% will be equal to 16,000, right? So 80,000 plus 16,000 gives you 96,000. All right. So remember, 10% is equal to 8,000. So 20% is equal to 16,000. So that's how I got 96,000 over here. Now again, we have to increase it by 20%. 10% of this value over here is 9,600. So 20% will be 9,600 into 2. All right. So you have to add this value to 96,000, right? So how much is this? This is equal to 19,200, right? So you have to add 19,200 to 96,000, and that will give you 115,200. All right, so you have done it 2 times. You have to do it one more time. Now when you do it one more time, you can notice that the value will be greater than 124416, right? So you don't actually need to go ahead and calculate it. Why is that so? What is 10%? 10% would be this much, right? So what is 20%? That would be this much into 2, right? So what is that? That would be 23,040, right? You can directly see that that would be greater than 124416, right? If you add these two values over here, you have 115,000 and you have 23,000. So when you add them, it's obvious that the value will be greater than 124416. So you don't need to actually go ahead and calculate it, right? So we know that answer option C is wrong, and we also know that answer option D and E are wrong. So the correct answer has to be one among A and B. All right. Now let's go ahead and try option B. Now let me make some space over here so that we can do that over here. All right, so let's go ahead and try answer option B. Now answer option B is 72,000. So I have 72,000. Let me increase it by 20%. 10% is 7,200. 20% will be 14,400, right? So 14,400 plus 72,000 will give me 86,400. Now let's again increase it by 20%. 10% of this would be 8,640. So 20% would be how much? It would be 17,280. You have to add these two values. So you will get 103,680, right? So again, when you add 20% of this, you will get to 124416, right? 10% is 10,368. So 20% would be 10,368 into 2. That's how you do that, right? So let's do that. That's 20,736. All right. So when you add 20,736 to 103,680, you will get 124416, which is what you have over here. Therefore, yes, the correct answer is option B, right? The correct answer is option B. Let's do this question. The population of city DEF is 300,000. All right. If the annual birth rate and the annual death rate are 10% and 4% respectively, calculate the population of the city after 2 years. All right. Pause the video and try to do this question on your own, and then we'll do it together. All right. We are back. I hope you've been able to solve this question on your own. Now let's do it together. Initially, the population was 300,000, right? And it's mentioned that there is a birth rate of 10% and there is a death rate of 4%. So that means you have to increase this value by 10% and you have to increase this value by 4%. All right. Now notice that it's the increase and the decrease is on 300,000, right? This is a common mistake. Now, if you do this like this, let me show you what could be a possible mistake that you do, right? So if you do it like 300,000, if you increase it by 10% and you get a value, and if you decrease this value by 4%, that's wrong, right? So that's not what is given, right? The birth rate and the death rate are on this value. That is, you have to find 10% of 300,000 and you have to find 4% of 300,000. All right. So let's make some space over here. Now you could do that way, right? You could, that means you can do it like this. Let me write it over here. You could do over here 300,000 into 10 by 100. So that's plus because that's an increase. And then you can do minus 300,000 into 4 by 100 because that's death rate, right? So you can do it like this, but actually you don't need to, right? You can see that this just means that there is a net increase of 6%, right? How do I get that? Let's club this part. Let's take it out. So this becomes 300,000 into 10 by 100, right? That's 10% minus 4 by 100. That's minus 4 by 100 because you have a minus over here, right? So this becomes 300,000 into 6 by 100. 10 minus 4 is 6, which is nothing but a net increase of 6%. All right. So let me make some space over here. This is the first point that we have covered over here. Now over here, we've seen that there was a birth rate and a death rate, right? So there is an increase of 10% and there is a decrease of 4%. All right. So over here, this means that there is a net increase of 6%. Now let's go ahead and solve this. Now 1% of 300,000 is equal to 3,000. Therefore 6% of 300,000 will be 3,000 into 6, which is equal to 18,000. Therefore 300,000, when you increase it by 6%, you will get 318,000. All right. So this is after 1 year. Now we need to find the population of the city after 2 years. So again, you have to increase it by 6%, right? So 1% over here would be equal to 3,180, right? So that's this much. To find 1%, you have to just put the decimal place 2 places from the right. That's right over here. That's how you get 3,180. Therefore 6% will be 6 into 3180, which is equal to 19,080. So you have to add this value to this value over here, right? So 318,000 plus 19,080. So that would be equal to 337080. All right. So you can see that that's the value given in option A. Therefore, the correct answer to this question is option A. Hi students, let's now discuss what we mean with SAGR and CAGR. In this video, first let's discuss SAGR. Now SAGR stands for simple annual growth rate. All right. Now let's take an example to understand this. Now let's try to think about a bookshop. All right. So the bookshop is selling books. Now the years that we are trying to think about is 2019, 2020 and 2021. We're trying to look at the sales of books of this bookshop. So in the year 2019, let's say 1,000 books were sold. In the year 2020, 1,100 books were sold. And in the year 2021, 1,200 books were sold. All right. Now let's try to find out the SAGR or the simple annual growth rate of the sales of number of books for this bookshop. For this, we look at the initial value, which is 1,000, and we look at the final value, which is 1,200. All right. So we first try to find out the percentage change when we go from this value to this value. The percentage change is obtained by change by initial value into 100, right? We have seen that before. So this is equal to change, which is 200 by 1,000, which is the initial value, into 100. So that's 200 by 1,000 into 100, right? So these two zeros cancel out, then this zero and this zero cancel out. So this is equal to 20%. So over here, we can see that the percentage change is 20%. Now you can see that this happened over 2 increases, right? So this is the increase over year 1 and this is the increase over year 2. So this has happened over 2 increases, right? Now because this happened over 2 increases, we have to divide this 20% divided by 2. All right. And that gives us 10%, which is what we call the SAGR. All right. Now you can notice that the SAGR is nothing but the simple interest. So the SAGR is the same thing as the simple interest. All right. Now let's try to understand why that is so. Now I have obtained the SAGR as 10% over here. Now let's find 10% of the initial value, which is 1,000. So 10% of 1,000 is equal to 100. All right. Now you can see that there's an increase of 100 over here and there is an increase of 100 over here. All right. So that means there's an equal increase, which is what we mean with simple interest, right? So if you had applied 10% simple interest on a principal of 1000, after 1 year it will become 1100, and after the second year it will become 1200. All right, so the SAGR is nothing but simple interest. It's the same thing as the simple interest. Now let me tell you one more thing. In this example, I've taken it as an increase of 100 and an increase of 100. All right, now let's say it was the case that initially it's 1000 and then it became say 1050, and afterwards it became 1200. All right, so it's not uniform, right? In this case also, the SAGR would be nothing but 10%. All right, so the SAGR is actually the rate which would be uniformly applied across the years to arrive at the final value from the initial value. It's like an average. All right, so again, if you find the SAGR, in this case the percentage change is 200 by 1000 into 100, which is 20%, which is happening over 2 increases. So 20 by 2 gives you 10%. So the SAGR in this case also will be 10%. Now let me quickly summarize. The SAGR is nothing but the same thing as the simple interest. How do you find it? You find the percentage change and then you divide it by the number of changes. So in this case we found 20%, that was step 1, and then the number of changes is 2, so 20 by 2 gives 10%, which is the SAGR. Hi students, in the previous video we discussed SAGR or simple annual growth rate. Now in this video let's discuss CAGR or compound annual growth rate. All right, now for this let's take an example. Let's say the sales of a book, let's say in $1 million it's 100 million. After 1 year it became 110 million, then it became 121 million, and then it became 133.1 million. All right, and you're asked to find the CAGR. Now let's first try to see how you can find it. Actually you want to find the compound annual growth rate, right? There's a growth rate in sales, right? This is 100 million, this is 110 million, this is 121 million, and this is 133.1 million. Now increase has happened over 3 periods, 1, 2, 3, right? So the increase happened over 3 periods. Now how do you find the CAGR? The CAGR can be found out in the same way as you would find the compound interest, right? So how do you do that? This is the amount, right? This is the principal, and you can write that principal is equal to the amount is equal to principal into 1 plus r by 100 to the power 3, because you have 3 periods over here, right? So 133.1 is equal to 100 into 1 plus r by 100 to the power 3, right? Now in a question, if you were to find this, you would have to plug in the values of r, right? Because we don't want to find the cube root and find it out, right? That makes it more complicated. The easier way is to plug in various answer options into r and to find the correct answer. All right, so that's how you would proceed for finding the value of r in a real question. Now over here, let's just go ahead. That would mean 1.331 is equal to 1 plus r by 100 to the power 3, right? So I just took 100 to the left hand side. So in this case, you can find that r is equal to 10%. If you plug in the value of r as 10%, you will get 1 plus 10 by 100 to the power 3, which is 1.1 to the power 3, and 1.1 to the power 3 is nothing but 1.331. So the rate of interest, or the CAGR, compound annual growth rate, in this case is equal to 10%. All right, now what does this mean? It means that there's an increase of 10% over here, so 100 becomes 110, and again when you do a 10% increase, 110 becomes 121, and if you increase 121 by 10%, you get to 133.1. now notice that compound annual growth rate is the same thing as compound interest. All right, now one more side note. Over here we have taken a constant increase of 10%, but let's say 100 became 105 and 105 became 110, and from 110 it became 1331. Now you want to know the CAGR over this time period, right? So again the value would be the same, right? It's actually finding the average. It's actually finding the rate at which, if there was a constant rate of improvement, what would be the rate? That's the CAGR. So even if the case is 100 becoming 105 becoming 110 becoming 1331, the CAGR would still be the same. That is, you're going from 100 to 133.1 in a matter of 3 periods. So the equation is the same, and you would get the rate of interest or the CAGR, the compound annual growth rate, as 10%. Hi students, let's do this question. A company's sales was 10 million in 2018. In 2021, the sales increased to 17.28 million. Find the CAGR of sales of this company. Alright, so pause the video and go ahead and find the answer, and then we'll do it together. Alright, we are back. I hope you've been able to find the answer. Now let's solve this question together. Now what's happening over here? The sales is going from 10 million to 17.28 million in a matter of how many years? In a matter of 3 years, right? That's 2018 to 2021. So let's say this is at the end of 2019. All right, so this is 2018. Now when it became 2019, you have some value. All right, again when it became 2020, you have some value, and then when it became 2021, you have 17.28. all right, so you can see there is 1, 2, 3. There are 3 increases. All right, so to find the answer, you have to try the options. That's the best method. All right, now over here you can see that we have 20% over here, right? So and you have 10% over here, then you have 12, 14 and 24, right? Among these, 10 is very easy to try out and 20 is very easy to try out. All right, now let's try 20, because if either 20 is right, I get the answer. If 20 is wrong, I can also eliminate 24, and I just need to check these 3 answers, right? If I check 10, if it's right, I get the answer, but if it's wrong, I still have to check all the 4 answers. So it's better strategically to try 20%. So let's go ahead and try 20. All right, so if 10 is increased by 20%, it will become 12, right? Why? 10% of 10 is equal to 1, and 20% is 1 into 2, which is 2, right? So 10 plus 2 gives you 12. Now let's increase 12 by 20%. So 10% of 12 is 1.2. So 20% of 12 is 1.2 into 2, which is equal to 2.4. So 12 plus 2.4 gives you 14.4. all right, now you have to increase 14.4 by 20%. So 10% of 14.4 is 1.44. Now 20% of 1.44 is equal to 2.88. So 14.4 plus 2.88 gives you 17.28, which is correct. So therefore our assumption was correct, and therefore the correct answer to this question is option D. All right, now you can go ahead and try some other options also. All right, so if you try 10, for example, let's quickly try option 10, which is option A. So 10 will increase to 11. all right, and 11 will increase to 12.1, because you have to add it by 1.1, and 12.1 has to be increased by 1.21. How much is that? That's equal to 13.31. all right, so that's 1, 2, 3. You have increased it 3 times and you're not getting to 17.28. so 10 is not the correct answer, and the answer is greater than 10. So that's why we tried 20%, right? So you're, in this case, you're just able to eliminate 10. In the case of 20, if that would have been wrong, we could have eliminated 2 together. And again, 10 and 20 are easy to plug in and check. So the correct answer to this question is option D, that is 20%. The CAGR, that is the CAGR of this company, is equal to 20%.